Right, so you'll notice in this one we have factorial. So that's a C cap by 2 by 4. You always begin with the number itself and work back. So if it was k factor next multiplied by, so we're just going to bear that in mind in the background, eating to 2 to the power of n minus 1. Now we can't use 1 because we have this condition here. It's 5 minus 1 factorial. Factorial is bigger than or by 2 by 1. Is that bigger than 2 by 2 by 2 by 2? So 4 by 3 is 12, by 2 is 24, by 1 is 24. 2 by 2 is 4, by 2 is 8, by 2 is 16. So tick, that implies that it is definitely true. Now we move to our assume. Our assume is P of k. Anywhere there was an n, we now put a k. So we rewrite our sentence with a k in the place of n. We then go to our prove sentence, prove P of k plus 1. So anywhere there was an n, we now put a k plus 1. So k plus 1 in the place of n on the left, and k plus 1 in the place of n on the right. I'm just going to tidy this up a little bit. So this just becomes k factorial, and this becomes 2 to the power of k. Now, with our inequalities, we always need to go through our steps. So we want to turn our assumption, we want to turn our yellow there into our proof, which is our pink. So how could I possibly make this into the pink? So if you look back on what we discussed a moment ago, k factorial is really k times x minus 1 times x minus 2 times x minus 3, etc. So if I multiply k minus 1 by k, so in other words, just put k in front of this, and of course, whatever I do on the left, I have to do on the right. So I also have to multiply this by k. What I now have is the pink, because k bracket k minus 1 factorial is exactly the same as me just saying k factorial. Because what we're doing is we're saying if you go down from there, it's the same thing as writing k. So just like 4 by 3 by 2 by 1 is the same thing as saying 4 factorial, k times k minus 1 is the same thing as just saying k. And then on our other side, we could probably just tidy this up a little bit. So that would be 2 to the power of k times 2 to the power of minus 1 times k. So I suppose the most simple rearrangement would be now 2 to the power of minus 1 can be rewritten as 1 over 2 to the 1 times k. So a kind of the most tidy version is really k over 2 times 2 to the power of k. Now you don't have to maybe bring it to that level of simplicity, but I think it's always good, because then when you go to do your proving steps, it's a bit tidier. So it is true if, so this is our true if sentence. If the adjusted, so this is the adjusted assumption, it is true if the adjusted assumption, so k over 2 times 2k, is bigger than or equal to whatever the proof was, the proof being up there where the pink is, 2 to the power of k. Now, can we see straight away that the left is bigger than the right? Well, we can, as long as k is a positive number, because if it's positive, then and obviously if it's bigger, bigger than 2 anyway, then no matter what it is, if I multiply it by 2 to the power of k, it's going to be bigger than 2 to the power of k on its own. So it is true if, and it's true as, or true because k is bigger than or equal to 5. Now I know that because n is bigger than or equal to 5, so k has to be bigger than or equal to 5. So you can always try it out if you want, put 5 in there or 6 in there, and you'll soon see if you do put 6, for example, 2 into 6 goes 3. So it'll end up being 3 bracket 2 to the k is bigger than 2 to the k, which it obviously is. So usually then we just rewrite the prove line, the last black line. So we have indeed proven that that is true. So then we do our generic, therefore, p of k plus 1 is true if pk is true, and that implies p of n is true for all n is an element of n where n is bigger than or equal to 5. And it is 5, isn't it? Yes, bigger than or equal to 5. And that one is done.